Hello. Today we're going to be looking at a new topic, although the topic is heavily connected to what you have already done. That's why you can see on the page right now graphs that we've looked at in previous lessons. But we're going to be looking at this term called gradient. That's what we're going to be looking at today. In order for you to understand what gradient means, we need to see lines on a Cartesian plane. So here we have two different examples. We've got example one right here and example number two right here. For us to understand what gradient is, we first have to understand that gradient actually means something like slope, or I guess you could call it steepness. When looking at these graphs, what we're going to do and what we're going to make sure that we always do is we're going to start from the left of the line walking towards the right. So just pretend that you're standing on that line. So here in this case, this is the line I'm talking about. And here in this case, I'm talking about this line right here. Okay. So we're going to pretend that we're a person on this line and we're always going from left to right. Here in this case, you're going left to right here. In this case, you're going left to right here. And what I want you to understand is that the measure of gradient tells you how steep a line is. And we can actually give a numerical value to how steep a slope actually is, or the line is. In this case, I want you to look at this guy right here, and I want you to understand that if you are going from left to right, are you going to go uphill or downhill? Are you going to go upwards or downwards? In this case, clearly walking left to right would make you go up the hill, which means this will be a positive gradient. We'll figure out what the actual gradient is, but we'll know that it's going to be a positive number. In this case, for the second example, you're walking downwards, hence this will be a negative gradient because you're going downhill. Okay, of course, there's one more example where you might have a Cartesian plane and the line is just a flat line like this. Okay, if you're on a flat line going from left to right, you're not going upwards, you're not going downwards. That is what we call a zero gradient. In other words, there is zero steepness to this line. It's literally flat. Okay, so that's what zero gradient means. Moving forward, I want you to think about a few things here. Okay, decide if the lines A, B, C, and D on this graph have a positive. These are terms: positive, negative, zero, or undefined. I'll talk about undefined a little bit later, but let's just do the first. Let's do the first three. Question: line A, the green line. You're walking left to right. You're clearly going downhill. So here, negative. You're going downwards. It's a negative steepness, negative slope. B, B. We'll talk about B later. C. Okay, C. You're going uphill because you're going from left to right, so you start from here and you're going upwards, so this is going to be positive. And finally, line D right here is literally a flat slope surface, so if you're walking left to right, there is a zero gradient, there's zero steepness to this line. Okay, you're not going uphill or downhill. B is what we call undefined, and I'll talk about this a little bit later. Some of you may understand why this will be undefined a little bit later, but just to let you know that a vertical line is undefined, because if you can try and imagine, it's so steep in a sense that it's almost infinitely steep. You can't go up the steep, right? So if you're going left to right, there is really no left to right in this case either, if you think about it, and so it's undefined. It's nothing we can define for ourselves. So that's how you classify or define a type of gradient. That's how you do it. Okay, let's try these. All right. Here is how you find the gradient of a line. So remember, a gradient, use this. The gradient is the steepness of a line that's going to be measured numerically, as in there's going to be a number answer. So in a way, I can ask you how steep the slope is, or what's the gradient of the slope, and you will tell me a number. We're working out what that number is, okay? Here's how we measure steepness of a line. What we do is we measure, we're going to look at these points. So we're looking at this point right here. And we're going to look at this point right here because it's given to us. That's the origin. That's 0, 0. Okay, so if you don't know this is 0.00. This is 0.23 right here. Okay, so the question is, how far vertical has it gone? And how far horizontal has it gone? So we're going to measure vertical distance traveled over horizontal distance, which is why this is how the formula actually is, so that you know gradient is equal to rise over run. That's what we call it in mathematics, rise over run. It's not a hard thing to understand. Rise literally means vertical because you're rising, you're going up. You're rising, you're going upwards. So this is called the rise. And run literally means, if you're running horizontally. So run is the horizontal distance. It sort of makes sense if you think about it. If you want to classify numerically how steep a slope is, you just measure how fast, how high are you going up as you're going horizontally. And so as if it's a massive rise and a small run, it's going to be a massive number, and hence the steepness of the slope is going to be very, very steep. But if you're only traveling a little bit vertically but a very, very long horizontally, it's going to be not as steep a slope. So in this case, rise over run, we can see here that we've gone upwards by 3, and this goes down to 0. So this is going to be 3, right? So from this point here to, I'll use a different color, you can see, from this point right here to down here, we know that from here to here it's 3 because it's 3 minus 0, right? 3 here because that's the y-axis, minus 0 because that's the other y-axis. And the other one for the run, we can see from here that's 2, and then from here it's 0, so it's 2 minus 0, which gets you to 2. So this is going to be 3 over 2 over 2, okay? And that's your gradient. The gradient of this line is 3 over 2, or 1.5. Okay, if you were to convert it to a mixed number. Let's take a look at the next one. I'll just, before I go to the next one, just realize that this is a positive number, which makes sense because this is a positive gradient. You're going up. And what this actually means, if you think about it, it means for every step you walk, let's see if I can highlight this. For every step you walk horizontally, you are actually walking 1.5 steps vertically. That's what this line means, right? If you can see that, for every 1 step you take on the x-axis, you're taking 1.5 steps this way. This is the 1.5 steps right here. That's what gradient tells us. Okay, let's try the next one. Okay, straight away you should be able to see that this is a negative gradient line because you're going downwards. Okay, this time they're giving you 2 coordinates. They're not giving you a 0, 0 that doesn't exist. You're looking at these 2 coordinates. So what we're going to do is have to understand something really, really key before we do this question. Gradient is equal to rise over run. Remember, we're always going from left to right. So if I'm going to left to right, you should be able to see that this vertical distance from here to here is 4, but however, you're going down by 4. You're not going up by 4, so you're traveling this direction. You're not traveling this direction going upwards. This time you're going downwards. So this is actually 0 minus 4, okay? Because you're going downwards, turns into negative 4. This is negative 4. And underneath, this is still going to be a positive direction, right? Because you're going left to right, like we normally should be. So this is 4 minus 0 because of this 0 right here. Okay, so this is 4 minus 0. 0 is right here. So here I have 4, which gets me to be negative 1, which is the gradient of this line. Okay, that's a basic way of understanding gradients. If you want more of a systematic way of getting rise over run, that's very straightforward as well, but it's you choose which way makes more sense to you. Okay, for the rise over run, there's actually an extra part to this formula if you want to use it. How it works, I'll write it down here so you can see the graph while I'm doing it. Gradient is equal to rise over run, which is equal to the second y value, which is the y value closest to the right, minus the first y value, which is the y value closest to the left. And then we have the x value, minus the x value. So this is the x2 is the value on the right, x1 is the value on the left. So I'll highlight these so you can see them. Okay, this is y2 and this is y1. Let's see where y2 is. Y2 is the y value on the, so look at this coordinate. It's the y value on the coordinate on the right hand side, and then the y1 is the y value of the coordinate on the left hand side, because remember we're always going from left to right, and so because we want to find the difference between them, we had to go the right one minus the left one. Okay, x2, x1. Okay, we're just looking at the x coordinates now, so not the y coordinates but the x coordinates. So for x2 I'm looking at the x coordinate on the right coordinate. For this one I'm looking for the x coordinate on the left coordinate, and so rise over run would simply be just like we were doing before, 0 minus, oops, I'll use a color pen, 0 minus 4 divided by 4 minus 0, which of course gets you negative 4 over 4, which is the same answer again. Okay, and that gets you the answer. I'll highlight these values just so you can see them clearly and so you know which value, where these values are coming from. Okay, but these are the values that we've been getting to get the gradient. So hopefully that helps. Give it a go, see how you go, and if you have any questions, I'll answer them more in the next lesson. Hope you have a good time. See you later.